At this time, I would like to introduce our speakers for today. James Amanian, Senior Director of the U.S. Federal Technology Office at CyberArk, and Matt Topper, President and CTO of UberEther. Gentlemen, the floor is all yours.
Thank you, as always. So James and I wanted to dig in a little bit today about the changing world of identity. And the more and more we're seeing in the world, right, more SaaS providers getting FedRAMPed, more multi-cloud hybrid efforts on agencies, right? It was 2-3 years ago that agencies were talking, oh, which cloud provider are we going to pick? Not how are we going to use all these cloud providers? They were just thinking there'd be one. And with the advancements in tech, right, I'll point to the big part of the AI craze as part of it, and different vendors having different capabilities between Microsoft's partnerships with OpenAI, Google and Amazon and their partnerships with Hugging Face, which is an awesome company name. But right, some of the best LLMs in the world are coming out of kind of the GitHub for large language models. It's no longer just, oh, how are we going to move all the stuff from the data center into this one new cloud provider we picked? It's how the heck are we going to get our arms around all of this, especially when we don't control, in most cases for the SaaS providers, even the accounts or how your organization's data is shared, secured, and make sure it's not stolen. So we're going to dig in a little bit today about some of those challenges, but more so an approach to solving it. And some of the thoughts on the approaches to solving it that I've seen with agencies lately leave me with a large amount of worry, because a lot of them are vendor-specific lock-in with vendor-specific agents that go on endpoints that only work with those vendors' specific tools and interfaces, and they're not based on standards, which I don't know that it's a problem that needs to be properly solved, and picking one vendor will never fix it. So we're going to start digging in. In general, where we're seeing the biggest challenges right now is these distributed systems are all over the place. Right, a lot of times organizations will point to a shared customer responsibility matrix. And a lot of times when customers sign up for their SaaS products, they don't realize how much is on them to properly secure the services that they're buying. I think we've seen with a lot of the hacks and breaches that have happened lately, a lot of the tenants of these SaaS providers don't realize that there's not much they're responsible for in most cases, and it's really on you to lock it down. Moreover, a lot of times there's certificates based in or specific metadata or API keys that have been hard-coded for years. And these keys end up getting checked into GitHub, right? There are attackers that are just looking for GitHub check-ins with keys in them and have automated tools to look at the keys and go, oh, that starts with AK. I know that's going to be a Microsoft key. And as soon as they see those check-ins go into a repository, they're stripping out those keys and trying them on interfaces, completely automated, right? And moreover, as those keys start getting distributed out, or there's many different places to manage those keys, if those are all identities, whether they're human or non-human, right? A lot of times an API key is really just another username and password. And the only problem is when that username and password gets compromised, you get access to pretty much the entire database. And right, we've seen that's how the attackers have pivoted, is going right after identity first. And having these long-lived credentials are hell, and really what's going to kill us if we don't come up and use some better approaches. James, what else are you seeing? Because you see it from a different side than I do on a regular basis.
Yeah, and you've got up some great ones. What we like to frame it at CyberArk are there's new identities, new environments, and new threats, and it goes against all those themes that you just talked about. So on the new identities piece, we have workforce people, we beyond the IT admins and the system administrators. Now we have people that are going into SaaS applications with very powerful privileges. We have DevSecOps people developing software with those keys, with key vault sprawl all over the place. And then we've got machine identities behind that. So whether that's a machine identity acting for a human or machine to machine as part of a whole process there. So that's the new identities piece. You talked about the multi-cloud piece. We see organizations in a hybrid environment, and I don't think that's going away. Organizations are going to be on-prem, they're going to be in multiple clouds, they're going to be mobile, and they're going to be distributed, maybe even globally distributed for some of the federal agencies. So how do you account for all of that in your threat modeling, which leads me to the last one, is to new threats. You talked about stealing these keys. A lot of the attacks, especially recently we've seen, is adversaries are entering post authentication. So that's after the MFA has been done, often with these session cookies or keys. Then now they're running around. So how do you understand your environment enough to, if the assume breach mentality, which many of us have been practicing for over 10 years now, you take that all the way into zero trust that we've had. How do you implement that knowing that there's somebody running around? And normally it's going to be able to trace that back to identity and how an identity is being used or misused. So again, new identities, new environments, and new threats is definitely something that the agencies have to be dealing with today.
Yeah, and I think that pretty much sets up our next slide. Right? The history of a lot of identity in the service accounts or even the mutual TLS certificates of the past have been really static solutions. Right? We've got normally in the federal government, we're seeing certificates cut for 3 years at a time. And Google has stated to the CA browser forum that 90-day certificates is all they're going to accept. And they threatened to already pull that plug and start enforcing it this year. There was some pushback, but I would say by the end of the calendar year, we're going to go back to that time. And I know both of us are old enough to remember, but where you had the little red lock icon because the site wasn't under HPS. And Let's Encrypt came along and helped us automate a ton of that out. But that same red lock's about to start showing up again for any certificate, for any browser, any service, any endpoint, where the life of that certificate's more than 90 days. And I don't think most government organizations are able to move that quickly. Most I'm seeing are a portal that's built into ServiceNow or a custom portal that comes with the CA vendors that you have to upload a CSR file, and then somebody's got to approve it, and then they probably email it to you, and then your administrators manually putting that back in. That's been kind of that static past. Are you seeing anything newer getting pushed forward? Or is that still kind of it?
Yeah, no, you've described the situation well, I think, today. The piece I'll bring out is this just explosion of identities, whether it's certificates or being able to assign the machines. CyberArk Research has done a study last year, actually, that's for every one human identity an organization has, there's over 45 machine identities, right? So this concept of being able to manually issue identities, manually issue certificates, and then track them. And then what we didn't talk about before is how do you revoke them? So now, all right, so we know that this identity is bad. Well, where is it used and how do we revoke it? I think that's often broken in a lot of processes.
Yeah. And yeah, that I don't think many people realize that 45x multiplier, right? They're like, a lot of agencies where I'll see an RFP or an RFI come out, they're like, oh, we've probably got the same number of machine identities as we do humans. Well, we all think about our home lives, right? You've probably got a corporate laptop. You've probably got a personal laptop. You've got one or two phones that go on the same path. You've got, right, probably an Alexa or some kind of home automation device, right? We all have at least 5 devices, let alone the 45 services that those devices are connecting to, right? And each one of those is a managed non-person entity.
Correct.
So, yeah, we'll get into a little bit. So, in general, this idea of workload identity has come out in the last year, and I think as a industry, we've struggled over the last decade of what do we call this, right? There's been in federal government, we've called it non-person entities or non-NPEs. If some people have described it in government as anything that's not a carbon-based life form. So I'm still waiting for my dog to get a cat, but probably has a YubiKey on its collar by now with the ones I carry. But yeah, and yeah, we're looking. They've got like GPS enabled, cell phone enabled dog collars now that you can just draw a boundary. And I'm like, they're like, I want to break one apart and just figure out what the security on it is, and that's the nerd in me. But we used to call them service accounts. We used to call them right database credentials. We'd call them machine certs, machine to machine connections, and all of that has been wrapped up into workload identity now. And you might have a personal device that runs workloads on your behalf that then, right, you want to authenticate that device to the network, but also the person that's using it. And that can change in kiosk modes, but that device cert and essentially all of the attributes tied to that device from a security perspective should stay the same. And then that carries obviously onto all the web applications, to the app servers, to the service meshes, to the API endpoints, the graph databases, and everything behind the scenes. And then we start crossing cloud environments, crossing on-prem environments, crossing now edge devices that are coming back. I love the fact that we're going back to edge devices and putting servers back at stores, and right, Home Depots and Chick-fil-A's all have little data centers running inside now because they realize, oh shoot, if Chick-fil-A can't take orders at lunchtime, we already know how bad that parking lot looks. Can you imagine if they weren't actually filling those orders? But right, all of that has to be managed, and there's got to be trust built around each one of those locations and deployments, and managing that distributed trust of, oh, we're just going to use the ACM inside of Google. We're going to use the certificate manager inside of AWS separately, and they may not be subs, and dynamically cutting certs. Like, that is a nightmare from an identity perspective, in the same way that we're just finally from a human identity side getting to single IDPs or better trust. We're just replicating the human errors on the machine side. What's your thoughts?
Yeah, the piece I would add is this concept of long-lived and short-lived identities. You kind of hit on that. So even in machines, think of the identity of a database. That's a long-lived identity. So there's a way that you want to process that again, revoke that, and rotate that. But then I'm now a Kubernetes container, and I may be short-lived, right? And I pop up, I pop that down, I inherit from somewhere else, I go away. So the concept of how long-lived these identities or secrets, may be is something that needs to be accounted for. So yeah, here we go.
No, yeah, I agree. I was just moving to the next slide. Didn't mean to cut you off.
No.
So thanks, Jess, for popping up question one. So what's the most significant challenge in managing identities within distributed systems? I'll let you all answer as we go through this, but just going to make sure everyone answers so you can get your CPEs at the end, and make sure we all pay our $75 to get our CISSPs renewed because of it. Sorry, soapbox of mine. So, right, we've talked about we need to simplify how cross-platform, how cross-cloud, how hybrid environments need to be more dynamic and better secured. And might have jumped ahead a little bit, but right, this is kind of the attacks we're seeing today. We're seeing those compromised credentials, whether that's a developer accidentally checking it into a Git repository, or it's an attacker who's gotten in through another way and pivoted into a system to take those credentials. We saw SolarWinds when that happened. One of the first pivots was straight to AD and ADFS internally at that point. It's crazy. SolarWinds has been, what, 6+ years at this point? But right, these same attacks are prevalent today. They essentially log in, took the signing and encryption certificate from the SAML IDP connection inside of ADFS, and then pivoted and essentially took those config files, set up their own identity providers, and they knew it was trusted at that point to Google Cloud and Amazon Cloud interfaces for companies, and they were just running their clouds dry. Or right, what we saw with MGM of sitting in the middle of essentially a credential provider that was copying passwords between on-prem ADs and a cloud identity provider environment. They sat there and the attackers just watched those come through and decrypted the commute, because it was, well, it's decrypted as it was going through the system and read it straight out of the logs. So all of that to say, right, compromised credentials, misconfigured IAM policies. I don't think most people understand how complex those configuration policies are in each cloud environment and how different each one of the cloud providers are to configure those and manage them. I know you all have been in deep at CyberArk with your tools to try and get your arms around it. So what have you guys seen?
Yeah, I mean, starting with that last point, if you thought the 45 machine identities per each human is impressive, there are, if you're in the 3 major clouds, there are over 40,000 different types of entitlements that you need to assign and manage. And again, you just cannot do that manually. And that's why we have these cloud break-ins, because there's over provisioning, or you think you've got one attack path shut down, but you've got this one other entitlement that allows the attacker to continue on. And so, that is a big deal to your points. And this, lack of monitoring and auditing I'll pick up on is another piece, that whether in the past, a lot of the controls were really about, securing the identity, making sure that the person is the person. But now, like I said, there's new threats where that person is the person, except somebody's acting on behalf of that person, i.e. the attacker. So you've got to understand, heuristically, is that normally used? How is it being used? Where is it being used? And is that normal? And that goes all the way to your point about the adversary or the attacker going after identity and becoming the identity. And we've even recently seen that with the Microsoft attacks, right? And the recent cybersecurity safety board review about how that happened. So, SolarWinds was many years ago, but I think you and I are saying today that there's a lot more work to be done to actually implement the lessons learned that we knew about that many years ago.
Yeah, it's insane. There's literally a dedicated weekly cloud security mailing list that the only thing it does is go across the cloud providers and aggregates the IAM policy changes by default against all of those. And if an API or an interface gets extended, every week, that list per cloud provider easily has over 20 changes listed across all the services, all the APIs. And I can guarantee most people listening, their admins haven't even thought or looked about that in 2 years, let alone every week. And trying to get people to manually manage and maintain those things and keep up with it is impossible, right? And that's huge power for some of the tools that you all at CyberArk have developed for the cloud security posture management side of the world. So, yeah, as we said, that 45 times more machine identities than human users, right? And of that 45 times more, 68% have sensitive access. So from right, we always look at the human from a risk perspective in getting into systems and breaking into things. And they have sensitive access, but a lot of times it's only to their own information, even in federal systems for employees or contractors, or the teams they manage, they might have sensitive info or specific accounts that they've been authorized to see or case files they've been authorized to see. But we now have 45 times more credentials, and almost 70% of them have sensitive access that a lot of times say, give me all of the information for the entire organization's case files, because the filter happens somewhere else in the path. And the lack of risk management that I've seen around that has been insane. So just as a quick review, the challenges of machine identity management, exponential growth, as we said, 40,000 different IAM policies, wrong button, across the cloud providers. Right? We've got a lot of Kubernetes clusters standing up and multiple clusters per cloud provider. Each one of those needs to be managed on its own and have some kind of certificates or secrets or account management associated with it. That those are all places and that those configurations can leak, or those credentials can go out on the web. You've got challenges of the software supply chain, of putting those into Git commits, or even pulling in open source packages, right? There's container images in some of our government systems that have the Hong Kong CA allow listed, right? And like, that's just because they grabbed them from a public repository. But should we really, as a US government agency, even have that inside of the configs that run in our data centers? I would tend to say no.
Or is it allowed on certain applications and not on others, right? I mean, to your risk point, yeah, and do you have the visibility would be a major consideration for me.
Yeah. And then again, the traditional PKI solutions just can't keep up, right? A lot of it today is manual, either go to a portal, go to an email, or send an email to this group, go to this service now, send a signing certificate, and hopefully in 2 days it comes back. Containers are rotating like multiple times a day, right? Google, inside of their production environments, their certificates only last for 4 hours. And right, it's a giant culture change. I know that the DoD PKI teams are looking at a lot of their policies right now, and how are we going to manage the distributed trust? And right, a lot of times you'll have an Active Directory at a base or at a specific location, and there's a CA attached to that, and all the servers running there have their own CA that is kind of unmanaged. And how do you get your arms around that to say this whole domain has been compromised? It shouldn't be trusted anywhere else, and centralize all of that management of all those CAs. So with that, we're going to dive into.
Can I make a point here, Matt?
Yeah.
Yeah, I think it's important for everybody here to realize that you and I aren't saying that public key infrastructure architecture or process is bad. What we are saying is that the current implementations of people, process, and technology around PKI is not what we need into the future. There's going to be tons of times where a PKI cert is going to be needed by sharing a secret, even in these dynamic environments. It's just that we can't scale yesterday's practices to what we need to solve today.
100%. Yeah, I actually, so we just popped up question 2, and we will hold it open a little bit longer this time. But right, PKI has a legacy of being challenging and hard, and a lot of that has to do with the way we manage or mismanage routes and how we have set up these processes to manually get the certificates, because we're tying their approval to a human inside of a chain, inside of an organization. And then right, half the time it's a contractor requesting it, and in 3 years when they go to request the next one, it's a different contractor, and you really don't have that. It's like faux trust in it. So how do we move that to trust in our pipelines and in our application flows, that we're building the same way we do identity human verification through IAL2 and right, all of that proofing at the beginning before we'll give someone a CAC? We can do the same thing with service applications and services, and where that data, where those applications are coming from, right? Just the trust in Google saying, hey, here's the CAs that we support inside of our data centers, pull those in. All of that needs to be kind of fixed. And the good news is this has worked at scale within many, many companies globally. We're going to dig into Spiffy and Spire, which is a standardized spec on how to handle this. And CyberArk just made a pretty awesome acquisition of a company called Venify, who about 4 or 5 years ago bought a smaller company at that point called JetStack. And they're one of the leading providers of Spiffy-based solutions in the world. I know one of their implementations is supporting 4 billion nodes and endpoints with certificates that run for less than 4 hours at a time. And they had one of their global data centers compromised. And they were able to rekey that entire network in that global data center in under an hour. Can you imagine that trying to happen within one of the even enterprise Fortune 500 companies today, let alone some of the federal government agencies we both work with? It's pretty amazing the speed and scale at which they can run. And given a bunch of this automation, it also gets rid of a lot of those challenges we've always had with PKI, where you can start putting dynamic attributes inside of a certificate because it's only going to last 4 hours. And then in 4 hours, you're going to get the person's new attributes and roles and entitlements, or the services roles and entitlements automatically updated. So dig in with that one. So Spire is so you've basically got 2 pieces here in the world. You've got Spiffy, which is the standard for workload identity management across platforms. So there are open source implementations of this. Majority of your Kubernetes providers like Kubernetes itself would use Spire, which is an implementation of this. Microsoft, if you look, it's called WS:/WAC on their URLs, is their workload identity. Basically follows that same Spiffy standard. Amazon has it. Even Red Hat has it inside of OpenShift. It's really become that standard for workload identity certificates in production environments today. And the benefit is it is hooked into your workloads, and it is transparent to your underlying applications. So this isn't just Kubernetes. This isn't just fancy new stuff. This is completely transparent that can happen within your existing applications that, the application developers don't even have to think about and manage. You can do Spiffy with something called EBF that is built into both the Windows and Linux kernels and has been for 4 years and works great to insert and manage these certificates for the interfaces on the machines and dynamically rotate them without changing a single line of code. So essentially what happens is as soon as a service comes online, you have a policy that states, what does it mean that this service is good, right? That means it runs on this IP space. That means it runs in this Amazon account, or you've got a check that's strong enough to say it came from this container repository that we own through a signed pipeline, all the way back to assigned developer check-ins. The policy is up to you. But once you pass that check mark, it'll go and say, okay, I've got a new service that is coming online. It's this service name. It's this sometimes host name, but mostly we want to be looking at service names. And it'll go out, make that certificate request, and generate it. And as soon as that policy passes, it's good. And then if you have a policy that says that cert's only good for 4 hours, in 3 hours and 45 minutes, it's going to go out and get another cert, and another cert, and another cert. And you don't have to think about that anymore. You don't have to think about rotation. It's managed within a control plane. So that's within a cluster, right? Within a specific trust domain. And I hate trust domain as a word because it automatically makes people think of Active Directory domains in a forest. And it's much different than that because there doesn't have to be a hierarchy, right? You have a local trust domain, and those things get put into what's called a trust bundle. So all the services running within that trust domain, and I've seen organizations take that as by data center, right? Region, cloud provider, one for dev, one for test, one for prod within a single cloud provider, or have them by all of our financial applications are in this trust domain. Depends on your use cases, but once those trust domains are established, you can basically trade them around to all the clusters that need to share. So if you've got services in 2 different regions in the United States, you share the 2 trust domains, and everything between them is already trusted. When a service stands up and presents a certificate over to the other side, that other side knows where to go back to find out the information it needs to make an authentication authorization decision to say what applications and services should be here without having to explicitly do registries, do allow listing, do changes to firewall rules. That is what blocks a lot of our fast deployments today. James, saw you hit the mute button, so thoughts?
But yeah, I just wanted to make sure that so agree. And, the key point that you mentioned earlier was, the control plane and the fact that these are policy driven, right? So that really drives down, to your earlier point about human error, which is what we find happens during a lot of these breaches. So maybe the breach might be the phishing incident, but what really explodes the lateral movement is just one human error along the way. And the fact that now we're abstracting this layer so humans can understand it, we put it into policy. You can take policy and you have other tools to make sure that the policy is consistent with the results that you want. And then that automation process is all goodness.
Yeah. And from a government INA perspective, doing the ATOs, it's been great to be able to watch, right? Here's all of the policies that are signed by the agency. And I'm going to take that application, deploy it to maybe 50 locations. And once it goes to those locations, they can change the policies locally. But now from an IA perspective, they're only looking at the differences at each of those deploys rather than reattesting, reasserting the entire workload. And the reduction of effort on that alone has been amazing to see the speed with the agencies that have adopted this style to really get things done a ton faster and deploy new updates, deploy new configurations, and know what their risk looks like across without having to have a lot of manual reviews. So that really gets us into the dynamic nature of how this all works together. So we're going to dig into now just a little bit of one of the CyberArk products that I love the crap out of. And it's new to the CyberArk world, having come from Venafi, but it's called Firefly. And what that does is it sets up all of these trust domains, all of these bundles at all of your cloud service points, right? Everywhere you've got an entry point into a service, an application, a different cloud provider, a on-prem data center, a flyaway kit that is being deployed in a disaster response scenario. It sets up and defines how everything from the outside coming in is trusted, as well as all the applications, services, and people within as a single control point for that deployment. And then that goes up to a cloud controller or a configuration controller that orchestrates this across. So it does the implementation of Spiffy and Spire. It makes it much, much simpler for an integration, a management capability, all of the self-service pieces of the service meshes we see today that are based on Istio, on Spiffy, on Spire. It has the same standards and interfaces provided, but gets rid of a lot of the developer pain and manual deployment tasks as part of it. And then it also provides that GUI from a compliance and control perspective to say, what's changed? What's different from what was signed at the factory, right? It's kind of I'm a big car guy, so it's the Magnuson Mossad to when you want to put aftermarket rims on your car to look flashier, right? They can't decertify and de-warranty your entire car, but they can definitely say your axles are not warranted anymore because, right, you've got giant rims that should have never been on this car and they weigh too much. So the same thing is, hey, we're looking at this control plane of this cloud service, and here's the things that have changed. Instead of trying to look at all 40,000 policies, here's the 10 that are different. And that's all we have to worry about from a security perspective of what we know we shipped from the source. So within Firefly, it'll allow you to take, right, you don't have to deploy CyberArk CA. You can use the existing CAs at the cloud providers themselves, that you don't have to rip and replace what you've got. And the nice part is it will centralize and manage it all together. So, right, traditionally we would see something like an enterprise PKI within many government agencies where you're getting your CAC certificates, your PIV certificates added to your physical cards or added to a YubiKey style device. And then also that's kind of the service interface to send that CSR request to get your application certificate. Right? Those still exist, and the control plane will attach to that and manage it. It'll also attach to the identity providers that you allow within your organization to say who should be allowed to get to those interfaces or not to get service account and machine certificates. But also, it'll plug right into your DevOps pipeline. So you don't have long-lived credentials anymore for a developer to check in code. Because we all think we take away someone's PIV or CAC when they leave an organization or disable it, and they don't have access anymore. Well, guess what? Those credentials inside of your enterprise GitHub, GitLab repositories, they live forever until they're revoked, and most organizations aren't managing them. So Firefly will help you say, okay, every check-in certificate, right? It's normally an SSH certificate that gets generated and put directly into GitLab or GitHub. It's only got a 15 or 20-minute window, which is enough for a developer to check in, watch a build break and go, oh, shoot, I forgot this piece of code, and fix it and not have to re-authenticate. But the next time they want to check in code, it's going to put them back through an identity provider to give them that short-lived certificate. And then we can bind the event to say, this is the event on the identity server that made sure it's James behind the keyboard, and someone didn't take that token off of his machine and move it over here to go check in code on his behalf without him even knowing. Because every time he's got to be in possession of whatever that MFA token is to establish that new session to get his new check-in. And the same thing across the cloud providers. As I said, it'll plug directly into Microsoft's certificate manager within Azure or Entra, whatever we want to call it this week. Same thing on the Google as well as AWS sides, right? They've got their native CAs with you can put your root inside of their HSM, or you can bring it as a sub of your certificate authority in, but whether it's their roots or your roots, it'll plug in and manage it. It's built a facade that makes it centralized across all of the environments. The power of that and the ability to set the policies, set the different trust layers, be able to dynamically revoke those things from one central location, no matter where these workloads are running, is an insane amount of power that when we say, right, zero trust, trust but verify, I don't think most organizations even know where those trust points have been defined. So I know this is a new application and solution within the CyberArk stack, but James, any experienced thoughts on Firefly and how it works?
Yeah, well, it like you said, brand new, but I think it just extends the philosophy of CyberArk. And you mentioned about no vendor lock-in. Well, here, I think the first point I should say, just like many of our tools, we got to meet the developer where they are, right? So it integrates with their current workflows and it integrates natively with their current set of tools. And that's probably, the number one requirement. The second piece is we can point to, like Matt talked about, other CAs. You don't have to use our CA. You don't have to use a specific CA, certificate authority. And many of our other tools, same way, don't have to use our IDP, but we do have that but you gain capabilities elsewhere within that tool or that capability set. And then the last piece I'll emphasize here is that there are other tools out there that often do pieces of this or just a piece of this capability or only in one cloud. And I think what the value of the UberEther stack, of CyberArk's tool sets often are, is the fact that we do it across more than one cloud, often all three, depending on how the development is. And then you do have both, what I really like to emphasize is that there's a unified administrative experience. So how you're administrating that control plane, you're not doing it across 3 different clouds or even 5 different clouds. And your users are seeing a unified experience, in this case, the DevSecOps folks. So I think all of those are what the value that we bring as a team.
And it's fully attested down to the human or the machine that's introducing any change policy anywhere along the lines, that you can always come back from an audit perspective and find out when, where, why, and how something got somewhere, and either continue to propagate those patterns or make sure they don't happen again. And that in itself is a huge time savings if an attacker does get in your network and start trying to move laterally across your networks, that you have one spot to find out exactly how that thing got there, or if it got there and you don't know about it, exactly where to go find it. So as James said, with the control plane, it is centralized management. Anywhere you have a Firefly instance, for anyone who's a developer on the webinar today, if you've ever used Cert Manager, whether that's getting a certificate with Let's Encrypt to protect a website, or dynamically generating certificates within an Istio cluster or a Kubernetes cluster, right? Cert Manager is essentially owned and run by CyberArk and Venafi as an open source product. And if you've used Cert Manager, you know that will run on any cloud, and through simple configuration changes, basically say, where's my CA? Where do I go trust to get these certificates, and how? Because sometimes it is still a CSR call that has to be done, and a signed cert's got to come back before it's put in. Or it can be an Acme dynamic call and look up and immediately put it back in place and verify that identity and workload through a TKIM call. Like, Cert Manager just gets rid of that pain for the developers. And all Firefly and the control plane are doing is automating the crap out of that, so that you don't have to think about that when you're deploying your Kubernetes cluster. And then when a new one stands up in your organization, that trust is automatically established based on your policies that you set on how that's going to roll out. So We want to pop up question number 3 to make sure everyone gets those CPEs. Thank you, thank you. And then, yeah, so as we just said, with Firefly, not only does it control at the cluster level, but it does come up and give you that enterprise look across the organization everywhere that trust is being defined and how it's being defined and what the policies are being put in place. And as I kind of said at the top of the hour, with a lot of the zero trust efforts I'm seeing in government and specific vendor products being picked, or a specific agent has to go on to all of these machines to make this work, that's really dangerous from a integration deployment perspective. That if that's your approach, you really should take a look at how far and for how long you're going to be locked in with that vendor. Because if you have to replace all of those endpoint protections with a new native tool from a specific, if you ever want to move away someday, you're in trouble. And something like Firefly and the control plane will let you decouple vendor resilience. You can step away from CyberArk tomorrow. I don't think you will, because the manual pain of doing this is not great, from someone who's been doing this at a pretty large scale with a government agency. But it gives you that ability without lock-in, and it makes CyberArk really focus on delivering value to you rather than just trying to get you in a stranglehold, which is why we love working with them. So, as we said, not only within a specific cluster, in a specific cloud, within a specific provider, it allows you to federate across all of them and manage those policies of how it happens and orchestrates that as things come up and online. It'll also let you orchestrate with other government agencies where you might need to trade API keys and interfaces and be able to share across government agencies or to civilian companies that you're getting information from or giving information to in a standardized and secure way, and completely automated, that if you want to trust their trust bundle from their trust domain, you can automatically update those. And if they make changes on their side, it gets filtered in without having to do a manual call of, hey, here's some new metadata. We need you to implement this. We're going live tomorrow. Hopefully that administrator, who's the one guy in your company who knows how to do it, is on vacation, right? We've all been there, and this gets rid of that pain. So again, also pulls that into the DevOps pipelines, right? Pulls it all the way from developer check-in into whatever your source code repositories are. When your pipeline has to go pull that source code change, pull container changes, do builds, do verify, there are no more static credentials that get put into those configuration files. They're dynamically generated at the time of need. That is a huge benefit. And they're generated on an ephemeral, right, essentially Docker container that comes up to do that build. And as soon as that Docker container goes away, so does the credential. So the only window of taking that credential is while that build is happening. As soon as that build's over, you can't use it. So if an adversary broke into it, they'd be gone, right? There's no way for them to reuse that after the 15 or 20 minutes that that's good for. And they have to maintain inside of your environment, constantly grabbing those certificates, which makes it a hell of a lot easier to find them if they are there. And then, right, hybrid PKI, as we said, it'll even bridge over to things like OpenID Connect or SAML if it has to, just depending on what the organizations you're working with have, or even if you have to use an API key, because that's all they have on the other side, well, it'll manage that centrally for you as well. So in general, as we wrap up, right, machine identity is growing immensely right now. And I wouldn't be surprised if that 45x keeps getting higher.
Yeah, we expect it.
Right? Like every time there's an IoT device that goes online, every time, right, there's a TV put in a conference room and a speakerphone, right? Those are all machine identities that need to be put in and managed. Right? it's out of control right now, and it needs to get your arms around it.
I was gonna say real quick, I mean, just think about it, that, the TV that you put into the conference room, so that's a machine, and then all the services that it draws from, right? It needs to draw for 4 or 5 services, so now it's creating it. So you can see how this is almost exponential.
Yes. And yeah, and when we've got things like comply to connect that says, hey, is that thing still secure? Well, not only is the thing, but also each one of those services has their own profiles, and the service they call back to are going to want to know what the security posture of that machine is. So now you've got an integration problem, right? Where if you move to SPIFFE and dynamic certificates on a set amount of basis, then your corporate policy says, yeah, this machine is good, trust us. And you're not trying to share all that data around and make it a nightmare across all the providers, right? Which increases your agility, reduces costs, and then at the end of the day, also improves your compliance across a government organization, that every second what service, what identities they have, what attributes are being used to authorize them, where they're being used, and if any of those patterns change, you get to spot them very, very easily, because, right, we always joke it's not the needle in the haystack in cyber, it's needles in a needle stack. Well, at least now that outlier is glowing red hot, because it looks way different than the rest of the ones, and makes it a lot easier to find really the problems within your networks. So with that, we will turn it over to any questions that the folks might have. And then if there's no questions, anything else, James, before we wrap up today? CyberArk's been super busy over the last couple months with FedRAMP authorizations and some other pieces.
Yeah, I'll
Go ahead.
give a second okay, if there's no questions. We've been, all this really has been privilege access management. It was just expanding out to all these different identities, whether it's the DevSecOps folks, the machine identities that we've been talking about today, and we just continue to innovate because the adversaries continue to innovate as well. And what Matt, I think, emphasized over the last couple of slides is really it needs to be a life cycle management, right? You've got to think about how are you managing these things over the entire life cycle. And again, if you try to do point solutions or you try to do it the old way, it may work for you, but over a year, over 2 years, you probably will collapse under that, or you'll just have increasing costs, right? The costs of your solution will just go through the roof. And in the end, for me, it's always about how do we deprivilege the attacker? The attacker is going to land on a box. There is no doubt, there should be no doubt in your mind. So how can we make sure that when they land on that box, that there's a minimum or maybe even no elevated privileges there? And if there are, to be able to track it off of that, because they chose the one that we are able to control. So yeah, again, we just very excited to be here at CyberArk. I think we're doing some great innovations to help the space, because I think we do need to defend together. So over to you, Matt.
Yeah. So, and just with that, we'll throw a pitch up for UberEther's IAM Advantage platform, because no one vendor can solve the zero trust problem. And even within the user pillar that we typically look at, even though the user pillar, at least the identity space, is broken into the device and machine and user and every pillar pretty much at this point, no one vendor can solve all of these problems. So we've taken the best of breed vendors that can run in any cloud environment, that can run in your existing data centers or completely offline and disconnected, and built them to work together in really the patterns that the government uses them and needs to secure their applications and services. So we have that available in a FedRAMP High environment. It is private tenant, so no shared data, no shared services. So you are completely secured and isolated to your own organization that acquires it from us. Moreover, above FedRAMP High, we also have it all the way up to Department of Defense Impact Level 5. So that's the most secure enclave you can have before you leave the internet. So I'm very, very happy to work with CyberArk and James and the rest of the team on these solutions to be able to bring them at the speed of need and really help solve these problems. So really you can go on and solve the rest of the zero trust issues and no identity is solved and secured for you.